we are finally here with the last question of the exam, the one that stirred a lot of controversy. So, let's have a look at this nasty question, shall we? We're given a family of functions, fn of x is equals to cos to the n of x, and then we're asked to derive a reduction formula before using it to find cos to the 4 of x, or the integral of. So, let's take their hints. In the first step, you're asked to show that cos to the n of x is equal to the integral of that, is equal to a very long expression on the right hand side. So we should start with the hint that they give us by writing cos to the n of x as cos to the n minus 1 times cos of x. Even without having heard of the term reduction formula, the fact that you have two functions multiplied together is usually a cue that you should use integration by parts. We know that u sub would not work because cos of x is not a derivative of cos to the n minus 1 of x. So u sub is not an option. If we're using integration by parts, let's just say u is equal to cos to the n minus 1, and dv is cos of x dx. Du is n minus 1 cos to the n minus 2 of x sine of x, and v is sine of x dx. Sine of x. Using integration by parts, it's u times v minus the integral of v du. There is a lot going on here. The first term is done. We can keep it there. It is also the first term in our result that we're asked to derive. So that's a very good start. In the second part, let's get rid of this. So simplify this guy a bit before further manipulations. We have this expression. Notice that our integral is entirely in powers of cosine, and we have sine squared here. So the only logical move is to use Pythagorean theorem, the Pythag identity, to change this guy, to express this guy as 1 minus cosine squared. This guy will give us the integral of n minus 1 cos to the n minus 2 minus the integral of n minus 1 cos to the n. Now we just gotta take the constants out of the integrals. And that, my friend, is the answer that they're asking us to derive. In part B, we are asked to use this result to find the integral of fn of x. Maybe the notation would throw some students off here, but the integral of fn of x is nothing more than the integral of cos to the n of x. Notice that we have two terms that are integral of cos to the n of x. That means we can combine them, we can bring them to the same side. And then divide by the constant to find this integral. This is very similar to what you did when integrating functions like e to the x cos of 3x, that you have to do integration by parts twice before you isolate the integral to write down the final answer. Let me just double check my calculations real quick. If I'm going to move this guy over, we're going to have n minus 1 plus 1, so it should only be n over here. And it should also only be n over here and n over there. In other words, the printed answer. This guy is simply f to the m f of f n minus 2 of x. Pretty simple and standard so far. Part C now asks us to make use of this reduction formula, the integral of cos to the 4 of x dx. This is essentially f4 of x, correct? Sorry, the integral of f4 of x. So let's use the reduction formula once, and we will see what we have there. So if n is equal to 4, the first term is going to look like this. 4 minus 1 divided by 4. The integral f of n minus 2 now becomes f of 2. We can even do this one more time. So I'm going to carry the first term down. This integral is going to be 1 by 2. Cos to the n minus 1 will now become cos times sine of x. N is equal to 2, so 2 minus 1 divided by 2. And the integral of 1 dx. So, the final answer, we would get 1 by 4 cos to the 3 of x sine of x plus 3 by 8 cos of x sine of x plus 3 by 8 times x plus constant. So this is your P, that is your Q, that is your R. End of question. The hardest part of question 12 is now behind you. Parts D and E are various applications of this function. To be fair, I'm not the biggest fan of part E because I don't know what the IB is trying to do. They make us find a Maclaurin for fn of x. Fair enough. Then we gotta use it to find a limit. Fair enough. But where is the link to the previous parts? That I'm not convinced. But anyway, we're here to do the question. Part D. Find the volume of the solid formed by the region R rotated 2 pi radians around the x-axis. So the volume is going to be pi times the integral from a lower bound to the upper bound of the function squared. In other words, this integral. Luckily, we just found this above. So all we're going to do is we're going to lift the answer from part C. So that's 1 by 4. Q is 3 by 8. And R is 3 by 8. We're going to plug the upper bound and the lower bound. A lot of students were intimidated by the first 3 parts that they should skip the entire question. Even if you cannot do part C correctly, you can assume the values of P, Q, and R and use it to solve part D. Or if you are feeling more adventurous, you can just keep the final answer in terms of P, Q, and R. As long as your working is consistent, you will still get full marks for that question part. So let's actually integrate this guy. Just gotta plug in the upper bound and the lower bound. So that's gonna be 1 by 4 cos cube of pi by 2 sine of pi by 2, 3 by 8 cos of pi by 2 sine pi by 2, 3 by 8 times pi by 2, minus the lower bound. So that's 1 by 4 cos cube of negative pi by 2 sine of negative pi by 2 minus 3 by 8. This expression is getting long. Okay. Negative pi by 2 sine of negative pi by 2 and 3 by 8 of negative pi by 2. Okay, this is looking quite convoluted unless we realize that cos of pi by 2 is equal to 0. Just quickly recode the graph of y equals to cos of x. It's going to go down, it's going to go up. So cos of pi by 2 is 0. That means that every single term with cos of pi by 2, that's going to be 0. Likewise, cos of negative pi by 2 is also going to be 0. That's gone. That is also gone. So the only terms that we need to evaluate are this guy, 3 by 16 times pi, and that guy, plus another 3 by 16 times pi. And your final answer would be 3 by 8 pi squared. 4 marks for this part of the question, which makes it even better because this answer is independent of P and Q. So luckily for examiners, they will not have to spend too much time to check for consistency. Moving on to part E. Part E is about Maclaurin series. So recode, this is your function. And you're asked to find the first 3 terms in the Maclaurin series. So fn of 0, that's going to be 1 to the n, or 1. Simple. The derivative of this is going to be n cos to the n minus 1 times negative sine of x. So the derivative at 0, that's going to be n times 1 times 0. 0. Convenient. Second derivative, I'm going to differentiate this guy another time. We have a product of 2 functions, so we got to use the product rule. So negative n times n minus 1 cos to the n minus 2x times negative sine of x squared. The second term, n times cos to the n minus 1 times the derivative of negative sine, so negative cos. This second derivative at 0 is gonna be negative n times n minus 1 times 1 times 0 plus n times 1 times negative 1. So that would be negative n. Therefore, the first 3 terms of the Maclaurin series, it's going to be fn at 0 plus the first derivative at 0 times x plus the second derivative at 0 times x squared divided by 2 factorial. So you should get 1 plus 0 x plus negative n divided by 2 x squared. Using this information to find the limit, we're just gonna slap our Maclaurin series for fn of x into the numerator. minus 1 divided by x squared. Sorry, this guy also has plus 1 minus 1. These two terms now cancel out. So all you're left is the limit as x tends to 0 of negative n by 2, or also known as negative n by 2. So this is the end of the examination. The last 19 marks are definitely challenging, but it is gonna be a very good discriminator between the 6s and the 7s. So yeah, have fun. Hey yo, so these are my comments for the M25 TZA Paper 1, and this is Andrew. I would say the paper is decently difficult. There are a couple unfamiliar questions. Questions 5, 6, 7, and 11b in particular. Those are the questions that you would not have seen coming. Questions 8, 9, and 12a, b, c are hard in their own ways. Question 8 is a bit tricky with the inequality. Question 9 is tricky with the algebra and justification of the removal of the moduli. And 12ABC is a classic reduction formula, which is not officially part of the course, but they have done this before. As per usual, good algebraic manipulation skills are crucial if you want to get a 7. A well-prepared student should be able to get around 90 to 95, and considering the difficulty of this year's paper compared to last year's Time Zone 2, I would say that the level 7 boundary would stay pretty much the same as before. Thank you very much for watching.